Hi. We'll get the second part of Chapter 2 on antennas and accessories. We'll look at antenna charts and take it all the way through antenna types and maybe a little additional hardware information for mounting purposes. So just a little bit more information on antennas. Now, one of the things that we concern ourselves with is how powerful an antenna is. And that pretty much is antenna gain. Now, antenna gain is measured in dBi. And of course, dB is, we've talked about in the past, but it's decibels, but it's got to be compared to something. And what dBi is, it's comparing a decibel to an isotropic radiator. And pretty much an isotropic radiator is a perfect antenna. It goes in a perfect circle, and of course, no antenna matches that perfectly. So it's just that comparison between power against this perfect antenna. So just know that when you're looking at antennas, you're going to see dBi as its content. So remember, an isotropic radio is a zero gain antenna, which means it radiates energy equally around the radiation point in a spherical pattern. Like I said, no antenna exists that way, but just to have something to compare against, that's the perfect way. Some of you, if you've been around antennas a while, you may have heard the term DBD, but that already had a dipole. It was comparing, the gain to a dipole, which had a 2.14 dBi gain already built in. So that became a pain, but you may still run across it in some of the older systems. Now, when you look at gain, knowing that a 3 dBi antenna radiates twice as much power as an isotropic radiator would. Now, we're not going to get into dB math in this class, but knowing that if I add 3 dB power, it doubles the power, and if I subtract 3 dB, it reduces the power in half. But we're not going to get into RF or dB math, but just know that it's a relative term to power. Now, when you get looking at antennas, manufacturers do a couple of things. They give you antenna specifications, and they talk about the different type of antenna, the frequency it's operating, what frequency range it's at, what its beam width is, some physical dimensions, what kind of connectors it's used. So those are things that every single manufacturer, I shouldn't say every, I'd say 90% of the manufacturers will give you antenna specifications so you know what you're purchasing, because you need to make sure you understand what connector type is required. But typically, this is what you're going to see: the type, the frequency, impedance, the frequency range, its peak gain. But the other thing they usually give you is antenna charts. An antenna chart is, it shows the expected coverage for this particular pattern. So in free space, this is what you're expecting the antenna to perform like. Of course, that's not if you're tweaking the power anyway or so, but it's important to know that this is the intended pattern. Now, there are a couple of different slices of this. One, you can look at the vertical pattern or the horizontal pattern. You see elevation in vertical, azimuth in horizontal. And if you look at how those are decided, those charts, just think of the position of the antenna. If the antenna is vertical, you get the elevation chart or the vertical chart. Or if it's horizontal, you get, you're kind of looking like on top of it. So you get, one gives a top side, one gives you a side view, one's giving you a top view. And every antenna manufacturer does this. Now, I've posted some different videos that shows you how this power is managed, but you can look at these are dB gains at a particular degree away from the antenna. This Omni one makes it pretty easy. It just shows you, hey, how much gain you've got. When you looked at the details of the chart, each one of these rings is some dimension of power, how many dB it is. When we get to other charts, as far as high power gain antennas, the shape definitely changes a lot, and you'll need to make sure you understand that. Now, there are 3 different types of antennas that are used a lot. At least in Wi-Fi networks, you've got an omnidirectional, which is 360 degrees. You've got patch antennas, which are kind of semi-directional, but they're made to be mounted on a wall or a ceiling and aimed at a direction outward. And then you get a high gain directional antenna, similar to like the radio, a dish antenna. But the directional antennas can be subcategorized into, semi-directional, sectorized antennas. You'll see some that are made only to do 60 or 80 or 90 degrees in a direction. If you're driving down the highway and you look at a cell tower, you'll notice that there are, in a lot of cases, antennas pointing in 3 different directions. They're using a directional antenna to cover that specific area. Now, a directional antenna has more gain in a particular area, which then means what? I get more coverage in a particular area, so that you see a lot of vendors, based on how much coverage they're trying to get, how much penetration they're trying to get, they'll use a directional. Now, your highly directional, that one's a satellite dish, so you don't be bouncing things off the satellite. But it was too expensive to run cable from one building to another, on a campus maybe, I may use a directional antenna, highly directional antenna, to let with a higher data rate, to be able to connect the 2 buildings together, and that would help. That, and some of those would be called like a Yagi antenna. So if I look at, now of course you've got some antennas that are made to be internal and external. The ones that are internal, they're great for offices. Internal, they're great for large coverage areas, and they're usually made sure they've got a weatherproof NEMA, I think is the term, casing to prevent rain and all of that stuff to penetrate and get mess up with your internal workings of the antenna. Not that there's a lot of moving parts, but you don't need rust and things like that forming over time inside that. Now, trick with some of this stuff is, how do I mount those? And you will notice that there are several mounting kits, and you just have to decide as to, okay, am I mounting it flush mount inside the building? Is it going to be on a pole? Is it going to be indoors? It's going to be outdoors. So when you're looking at an antenna type, you've got to look at how is it going to be mounted, and does that antenna manufacturer provide a kit for that mount based on the conditions you're doing? Is it going to be put on a pole? Is it going to be flush mounted to the outside of the building? All of those things come into play, because along with the kit, you got to worry about additional hardware. What kind of cable? What kind of connector? Am I going to have to amplify the signal to get from the transmitter up to the antenna? Do I have too much power and I've got to back it down? Do I have to attenuate that power because it's just too much power? So all of these things you need to take into consideration when you're selecting your antenna and how it's going to be insulated. So you'll look at the application, what you're trying to cover, select your antenna. It's going to be indoors, it's going to be outdoors. Then I got to worry about how am I going to mount it, based on, and what's that going to do? Then you can look at the antenna pattern, you can look at the antenna gain, saying, okay, this is what this antenna does. This is the shape it does. So based on its shape, then I want to put it at this location. That location means that I have to mount it a certain way, which then leads to mounting decisions. How is it going to be connected? What type is the connector? I think one of the items on the specification sheet showed you the connector type. That connector type then proceeded to help you choose that antenna. So if you're already in existing network and say, hey, we're running cable and it's only going to be RPTNC connector. Okay, so that means you've reduced the number of potential antennas only because somebody's chosen for you already how it's going to be connected. So a lot of those just come into play. So just a lot of little decisions, all based on what is the coverage and the capacity that I'm trying to put into the place I'm trying to cover by choosing the antenna, the way it's mounted, any additional hardware, cables, connectors, amplifiers, attenuators. All of those things come into play when you're designing your wireless network. So this chapter, we've looked at a couple of things. We've looked at what an antenna is, that it radiates electromagnetic waves. There are omnidirectional, which radiate energy all around in a circular pattern and actually looks more like a donut. When you're using an omni, more than likely, because it's in the 360 degrees, you will locate those in the center of your coverage area. If you're using a semi-directional antenna, they radiate in a certain direction, and that's anywhere between 50 and 180 degrees. There are some that you can get down as small as 22 degrees beam width, but normally it's between 50 and 180 degrees. Highly directional, they definitely go less than 50 degrees, range, and give you longer distances. Now remember, the azimuth or the horizontal chart shows a top-down view of the radiation pattern, and it indicates outward propagation, where the elevation or the vertical chart shows the side view of the antenna pattern, showing you what's the up and down pattern. Because then that tells you how close to the ceiling or the floor that I need to get based on how much is above and below, if you don't want to radiate to your opponent in the floor above you. You've got a choice of indoor and external antennas. When you choose something, you have to make sure that if it's especially an external, you're trying to connect buildings, you want to make sure you choose the right antenna to get you the bandwidth and the data traffic you want. Now, you get different types of connectors based on the antenna type, and looking at the different connectors, you've got N types and TNC and SMA connectors. All of those are different, and any one better than other? No, but they've just got, some of them got different sizes. Just be careful. So hopefully this chapter shows you a little bit about antennas and how it would apply to your wireless design. And if you have any questions on antennas, give me a buzz, send me an email, send me a text. Have a nice day. Bye-bye.